Again, we will cover today what used to take us about 2 weeks in 6th grade. The shortened, condensed version here, kids, is this. I will tell you what I see most people making mistakes in 7th grade now, so you probably won't make quite so many. When you're talking about place values with decimals, please understand this. On the whole number side, you know, this is the ones place. Wow. This is the ones place. This is the tens place. This is the hundreds, and so on and so on and so on. The decimal side is a reflection of that, except, ladies and gentlemen, please hear me clearly, there is no ones place. Okay? It's going to be an exact mirror of this, except there is no ones place. It starts with the tenths place and continues on from there. Hundredths, and it has to have that th, otherwise it's hundreds. It's hundredths place. And then you have the thousandths place. This thing's going nuts. And then you have the 10,000ths, wow, and so on and so on and so on. Okay, but I see too many people, for some reason, you know, I have a number like 524.26, and I ask what number's in the tenths place, they'll say the 6 because I think they think that this is the ones place or something. No, tenths place, right there. Okay. And then when you say or read these decimal numbers, how do I read this number here or write it? If you were writing this 572.3941, you can't write it like that. If you're writing it on a check, let's say you're buying something for, I guess I couldn't have that. How do you do that? It's pretty simple. You start with the left side of the decimal, 572. What is the decimal point? That should be the only time in math when you're reading a number you say the word and. 572 and, now here comes the sticky part. How do I do this? How do I say that piece right there? Anybody out there? Don't make me just talk to myself. I'm doing that. Maggie, how do I say this part of that whole number? Technically, children, when you write decimals, just like you put commas and big numbers on the left, you're actually supposed to put commas and decimal numbers like that, just to make it easier to read. When you say this number, you have to say 572 and you read this just like you would the whole number to the left. 3,941. And you have to finish it off with what? Yeah, whatever place that last digit is in. I think we probably should practice because nobody really seemed to enjoy it as much as I did. Who is number 4 in the class? Number 4. 4. Cameron, read that number for me.
40 and 63 hundredths.
Tenths, hundredths, thousands. 40 and 63 thousandths. Thank you. See, there is a balm in Gilead, as they say. Who's number 9? This is gonna be a long class.
300.
Wait. Okay, wait. Say it nice and loud. Loud and proud, baby.
378,340.
Very good. 378,342 hundred thousandths. Tenths, hundreds, thousands, 10,000s, 100,000s. Got that?
Yeah, I got that.
One more practice round.
Sure.
I'll give you the confidence even though we rarely see it. Who is number 17.
Yeah.
Alright, Schwartz, it's your moment. You could say 0 and, I'll give you that. How do I read this number here? Pretend there's no decimal there. Say that part first, and then worry about the next part. 9 what? $9,876,000. 354. Now we just gotta finish it off with a, not millions. Here's a little clue for you kids. This digit, you said 9 million. When you say it at the end, it's actually the next space to the left of that. When you say that, it's actually the 10 millions place. Okay. You might think it's millions because this is, you said 9 million to begin with, but it's actually one place more to the right, which is the 10 millionths place. Got that? Just like this was, remember this, we said 78,342. You'd think, because this is in the 10,000ths place, that that's the 10,000ths place. It isn't, that's the 100,000ths place. Does that make sense? Alright, so this number is 0 and, by the way, you don't have to say 0 and, you could just say 9,876,354 10 millions, if you really want. Again, not a whole lot of answer. Alright, what about this? Right out of the book it says to arrange these from least to greatest, 0.5, 0 or 0.41, 0.05, and 0.405. Smallest to biggest. Please understand, children, that with decimals, when you talk about whole numbers, as a general rule, the more digits a whole number has, the bigger it is. I mean, when you talk about whole numbers, like if you have 55 and you have 205, because this has 3 digits, you know it's bigger than that. That's not the case with decimals. You can't just use that rule and say that, oh, that's only got 2 digits, so it's going to be the smallest number. That's not true, because that's just not the way it works. You are allowed to add as many zeros at the end of things as you want. So probably your first step might be to look and say, okay, this has 3 places after the decimal. I'm going to make all of these have 3 places after the decimal. So I want to think about this as being 0.500. This as being 0.410, 0.050, 0.405. Then you get more of an idea which one's smaller or bigger, because then it's just which number is bigger. Which one is the smallest there, David?
0.050.
Right, because this is only 50 thousandths. So 0.05 is the smallest. Next would come, work with me here, people, Logan.
0.405.
Right, 405 comes next, because that's 410 and that's 500. 0.405, and then the next biggest one, Alex.
0.41.
Yep, 0.41, and then the largest one obviously is 0.5. And that's the same thing when you compare decimals. You know, I can have this 0.2 and compare that to 0.199999999999. Which one of those is larger? Caitlin Stritzel?
0.2.
Right, because I could put, really all you have to do is look at this. First place after the decimal is a 2, first place after the decimal is a 1, stop, that one's bigger, because no matter what I put after that 1, it's never going to get to be a 2. It's like the number 1 will be bigger than any single decimal number you could draw out here. 905, 905. Did you guys have a rough morning? Was that whole code red drill just kind of put you to sleep?
We're in there.
Well, so are we. No longer than we were. Alright, we're not done yet. Alright, Alright, how about this? How do you change fractions to decimals? How do you change fractions to decimals? You could put this under decimals. For example, this one. 8/10. Let's start with the easy stuff here. What is 8/10 as a decimal? Brooke Calla?
0.8.
Right, or 0.8. Why? Because that's 8/10. But what if you get to a fraction that is like this, 3/8? See, changing fractions to decimals are great as long as there's a 10 or a 100 on the bottom, because that's what decimals are, in tenths, hundreds, and thousands. For example, 15 thousandths is 0.015 thousandths. It's the same thing. But this one, what do I do with 3/8 to make it a decimal? Kayleen Schellhammer.
You divide 8 into 3.
Exactly. This you have to do by division. And you're going to take, and it seems a little odd, but you take the bigger bottom number into the smaller top number, and you need to do it until it either works out or it keeps repeating. For example, this one you get, 8 goes into 30, what, 3 times, that's 24. 8 goes into 67 times, that's 86. 8 goes into 45 times. The decimal equivalent of 3/8 is 0.375, or 375 thousandths. At this point, most classes sometimes stand up in class. Sometimes give me money. Alright, so let's look at if it happens to be 7/9. Yes, you're going to divide 9 into 7. How many times does 9 go into 70? 7 times is 63. You bring it down, how many times does 9 go into 70? 7 times, which is 63. Please don't spend the rest of your hour writing 7s up there. Once you see that it repeats and you keep getting the same answer down here, you just stop. 7/9 is 0.7 and the 7 repeats. Sometimes people do this, and while that's kind of true, and it is true, the double 7s also repeat. Usually we pick the easiest way to write it, and that would be 0.7. That's a good one to know about all of the 9ths, by the way. 1/9, 2/9, 3/9, 4/9. Guess what their decimals are? 0.1 repeater, 0.2 repeater, 0.3 repeater, 0.4 repeater. The 9ths are just funny that way. Just funny. Perfect, here we go. What about decimals to percents? How do I change decimal numbers to percent? Let's say I've got 0.23 or 3.2 or 0.006, and I want to know what those things are as a percent. Anybody? Easiest, best, and most efficient way to do that? Ryan seems to know. Well, let's go back to what we did yesterday when we changed, I think, fractions to percent. You can change anything to a percent by multiplying it by 100%. So here, and this will be the long way, but we'll do it. If I take 0.23 and multiply it by 100%, what is 0.23 times 100? Does anybody know? All right, you're going to make me do it. Let's do it like this. 100 times 0.23. 0, 0, 3, 0, 0, 0, 2, 0, 0, 3, 2. Move the decimal back 2 places. What percent is 0.23? It is 23%. How about 3.2? Do I have to keep doing the same thing? Am I going to multiply 100 by 3.2 and do all this out? Or the shortcut maybe is, well, it's always, with percents, there's always going to be 2 zeros, so it's always going to be 2 places. So 3.2, if I move the decimal over 2 places, is what percent? 320%. If I move the decimal over 2 places here at 0.006, it ends up being, David? 0.6%. Which is not, 0.6% is very, very little. You know, how about this? If the state tax was 0.6%, how much money would you have to give the government for every $100?
6 cents. 6 cents.
Well, think about it this way. If it was 6%, 6% tax on $100 would be $6, but it's not. It's 1 decimal over. So you wouldn't be giving them $6. You'd give them 1 decimal over to the left of $6, which is 6 cents, 60 cents. 6 pennies would be 0.06%. 0.06%, and that's because $100 is how many cents? $100 is equal to 10,000 cents. That's enough of that. Boy, is there more, kids? Oh yeah, how about this one? Write these 3 examples down. I told you this is more stuff than we covered in a month in 6th grade. How much is 80%? Let's just go, what is 80% of $40? What is 75% of $40? And estimate 8.25% sales tax on $19.95. These all fall in the same category here. Estimate 8.25% sales tax on $19.95. $19.95. Okay. Children, the reason the book throws these at you is to get you to be thinkers, which is a scary thought indeed. Okay. First of all, let's look at this here. The word of means in every one of these, guess what you're going to do? Yeah, that's the mathematical. Anytime you're finding of something, it's times. So this time, this is going to be 80 times. This is going to be 75% times 40%. This is going to be that times that. Now here is where you can do yourself some favors. Okay? There's no hard, fast rule about these, but you can make life easier by deciding. We don't deal well with percents when we do operations with it. We need to change it either to a decimal or a fraction. Those are your 2 choices. And sometimes it's better to do one over the other. For example, this one, and maybe it's different with different people. Do I want to make 80% a decimal and multiply it, or do I want to make 80% a fraction and multiply it? You can do either one, but one of them, to me, is a lot easier than the other. Think about what 80% is a decimal. What's 80% is a decimal? We just talked about it. 0.8. Do I want to multiply by 0.8, or what is 80% as a fraction? Claire? 8/10. Which one of those is easier to multiply 45? And it's different for different people. Maybe it's easier for one than for the other, but let's just look at what would be 0.8 times 40. You probably can do in your head. 8 times 40 is 320, right? Move the decimal back 1 place. It's $32. 8/10 times 40, if you just look at that, if you're good at cross canceling, it's pretty simple too, because 10 goes into 40 that, and you get $32. Which one is easier? I don't know. To me, that's kind of a toss-up here. How about this one? 75%, your two choices are to multiply by 0.75 or multiply by, what is 75% as a fraction, Brooke Kava? 3/4. Now, to me, I can do one of those in my head. I'm not real good at 0.75 times 40, though I probably could. But I can do 3/4 times 40. What is 3/4 times 40? Mrs. Stone, 3/4 times 40?
Oh, 3/4 times 40 is 4, 10, 30.
See? What about 0.75 times 40?
30.
Maybe you knew that because you just answered the 3/4.
That is.
So you get your choice. That's the whole point of the whole
Oh,
problem.
gotcha.
You get to pick which one is easier for you to do. Now,
Sorry,
then,
I'll be fine.
how about this last example here? I tell you, Mrs. Stone, did you have these kids for the code red? Because they are completely out of it. What, did you guys take a nap? I don't think they wake them ever since.
Well, I was outside and got dinged because I should have gone to the youth center, and somebody called them all back into the building where an intruder might have been. And we went and
You were
did
dinged?
B&B. It's like, well, you know, kind of goes with whatever. You guys
Did
could
we
go
ever
out,
go
lay
over?
down. Some of the kids even said, you could go lay out in the corner. I said, I'm not taking you to the corner, I would move you.
And do we have,
That's when the
wait, do you have keys to get in? Are we supposed to remember what the code is to get in there?
Well, I would have my emergency bag, and I'd have it. I should have just gone over and got Dave's house, but I should have done. Yeah, I know.
I never thought of that. I really should be prepared for that. There is a code to get into the youth center. But
There
there's
it is, and it's in my emergency bag, and of course.
I don't know where mine is. Remind me, we need to talk about that. I need to talk about that. But I do think the cornfield might. If you can't find them, then nobody else will be able to find them. Just remember that.
Hang out in the cornfield, ready to ambush us.
By the way, if you ever get in the cornfield and can't find your way out, what should you do?
Go one trip.
Use your cell phone.
Well, if you don't have.
Yeah, stay in one direction. Walk with the rows, I suppose, till you get to the end, because there's no way the rows can go on forever. Now, what happens if you're in one of those corn mazes?
You just plow through it.
Just plow.
Whistle as loudly as you can for Star Spangled Banner.
I just fly out of it.
Alright, right now, seventh grade, I want you, right now, estimate, and estimate by not writing anything down on your paper. I want you, other than the answer, I want you to tell me what you think 8.25%, if you were estimating this, you went to the store and you bought something for $20 and it was 8.25% tax. How much do you suppose you're going to pay in tax right now, Jack? That would be your answer. You should be able to make those numbers something you can deal with in your head and make it sound reasonable, see what you get. I want to see if you got any kind of clue about consumer mathematics. Now remember, this is tax, Grace Watson, so obviously on a $20 item, you're not going to pay $10 in tax because that would be a little outrageous, so consider that, keep that in mind. What do you think 8.25% on $20, how much do you think you're going to end up paying in tax? Because that is part of real life. Believe me, when you start having to pay tax, you start thinking about these things a little bit more. You got a number written down? I want you to circle it, star it, and asterisk it. Asterisk? A little star. It's like a hashtag, but not.
It's just made out of lines.
Lines? It is. Add the multiplication sign with the plus sign and rotate it about its center axis 10 degrees. Alright, let's see what we got. Everybody got their asterisk sign circled? Landon, what do you suppose? What's your guesstimation? $20 in tax on a $20 item?
Oh, no.
Oh wait, you added the tax with it? What was the tax with it? What'd you say? Wait, you had an asterisk. It's on your paper. What does your circled and asterisk thing say?
Well, I did,
You have to look down.
I just did the total.
Well, give me the total and I'll tell you what the tax. You said what, $20.43 did you
Yeah.
say?
I
So you said 43 cents in tax. Is that not right?
I said 48.
Oh, 48 cents in tax. What did you get, how did you get 48 cents in there? You're just guessing. Bellanuzo,
I think I did mine.
just give me the answer. Don't make apologies for it. That's why we're here in class, Luz.
Okay. $23 and
$23.75. So you're thinking $3.75 in tax. Caleb? I'd prefer just to tell me what the tax is, but $1.80. Julia? People, you guys are gonna go into stores and you need to know if you got enough money. Cameron? Not even a reasonable guess. Alex? $2.20. Ava? $2.15. Cabran? That's the tax?
No.
$4 in tax? Some of you guys should be thankful you live in the United States where we're not apparently taxed as much as you think you pay. Noah? $1.40. Brooke? $2.25. $2.30. $3.15. Ryan?
Around $2.50.
$2.50. Taylor? You guys don't ever take money into a store and buy anything? Fritzel? $5. Stoopfert? $3.50. Kayleen? You don't even know what would be reasonable and or appropriate amount of tax? David? Dollar what? $1.23. Schwartz? There's really no wrong answer at this point. $2? Cameron? $1.20. Claire? 16 cents tax on $20. Meg? $1.65 and Grace? $2.45. Now kids, you're making this way too difficult on yourselves. First of all, it said to estimate. So if you're estimating 8%, 8.25 tax, think about it as just being 8% tax. In 1995, thinking about it being $20 in tax. Okay, I can guarantee you people it's multiplication, so you know that 8 times 2 is going to come in there somewhere. It's going to be, your choices are this. You know 16 is there somewhere. So your choices really would be $16, $1.60, or 16 cents. Well, you could probably have 1 cent or 2 cents or whatever it is there. Now, if you don't, you should be able to look at that and think about what's reasonable and appropriate here. There's nobody's going to charge you $16 on a $20 purchase. So that leaves you down to 16 cents or $1.60. Well, $20 is a relatively, I mean, it's not a huge purchase, but it's not super small either. Okay, 8% tax on $1 is 8 cents. Because it's 100 cents, 8%, 8 out of 100 cents is going in tax. So if $1 is 8 cents, $20 would have to be $1.60. Mrs. Stone, some of these people would be very much in favor of a sales tax hike. Can you believe that? Thinking we should pay on $20, pay a $3 or $4 worth of tax on $20. Wait, can I help you with something? I know. Yeah, people don't. You don't understand that. Yeah, kids, you know what? You'd pay tax if you bought. What's a car? 30,000. Let's just say $30,000. So let's take it one step farther. You're going, and you do have to pay this on cars. 8% on $30,000. How much are you going to pay in tax? Now here, let me give you your clue again. You're going to take 8 times 3. Those digits are going to be in your answer. So your choices are, it's going to have something with a 24 in it. 24 cents, $2.40, $24, $240, $2,400, or $24,000. Which one do you suppose? Now $30,000 is a big chunk of change. Which one? 24 cents? $2.40? $24? $240? $2,400 or $24,000? Claire, who thinks $240 is probably the right guess? Nobody's not, $240 in tax on a car. Alright, who's not got their hand raised? Taylor, what do you think it is? $2. Taylor, we just paid on $20, we just paid $1.60. So we're bumping up to $30,000, and we think it's only gonna be $2.40? What about this? Who else didn't raise their hand? Stupford?
I said 2,400.
Yeah, it's $2,400. On a $30,000 car, you will pay $2,000.
I thought there was a zero on it.
Think about that. How about this? What game system do we run nowadays? Alright, how much does an Xbox cost?
Like
Oh,
Let's just,
like $300.
your Xbox, $350. You go to the store and, believe it or not, 8% is pretty close to what tax is. Actually, your floor is 8 3/4, close to 9. What do you suppose, how much do you suppose you're going to pay in tax on $350 at 8%? Unfortunately, it doesn't round up or down very easily, but you could probably get close to that. And again, here's the deal. It's going to be times 8 times 35 somehow in that. I don't know if you can do 8 times 35 in your head. You just roll it to, let's say it's on sale. $2,300. So your digits are 2 and a 4. They're going to be 24 cents, $2.40, $24, $240, $2,400. What do you suppose your tax is going to be? We got some answers here. Karan? $24 would be probably the right guess there, which is kind of reasonable. And a good indication is what's 10% of that? 10% is $30, so 8% is a little less than $30. Well, unfortunately, kids, we've way gone too far over